this week we're going to look at acceleration and how to work it out, and I'm going to give you the formula and then just go through a couple of examples with you so that you can then do the questions yourselves. So acceleration is when something is speeding up or slowing down, but it's not just how much faster or slower it's getting, but how much faster or slower it's getting in a particular period of time. Okay, so it's a change in speed or velocity, so a change in speed over time. Okay, the way that we work it out is we've got a formula that's similar to our speed distance time one, where you're either multiplying or dividing, and we've basically got acceleration is equal to the change in the speed divided by time. So change in speed over time. We then write that as A equals this little triangle. So that's how we write it. That little triangle basically means changing. So acceleration equals change in speed or velocity divided by the time that it takes. Okay. Now, because velocity is measured in meters per second and time is measured in seconds, what that then means is that units for acceleration end up being meters per second, which we write as either that, so m-s to the squared basically, or ms to the minus 2. So both of those are valid ways to write the units for acceleration. The key thing is you have to have that little 2 in, because if you miss out the 2, you're just writing down the units for speed rather than the units for acceleration. Okay, so that's the formula. Now what I'll show you is the different versions of that formula, and then obviously how to use it. So acceleration is change in speed or change in velocity over time. We stick that into this little triangle. Remember, that helps us to rearrange it. So because we've got this fraction here, the divided by, we have the same here. So we've got acceleration on the bottom, change in speed on the top, and then time. So remember then, to work out the other ones, you cover up the one that you want to know and then look at how the other two are arranged. So for example, if we want to know time, we would say time equals, put your fingers over that, the change in velocity is above the acceleration in the triangle, so it's laid out in the same way as this one. So change in velocity divided by acceleration. And if we're being asked to calculate the change in velocity, then say change in velocity is equal to, so cover that one up, these are next to each other, that basically means multiplied by, but remember we just don't bother writing the multiplied by sign in. So change in velocity is acceleration times time. Okay, so I'll just show you a couple of examples, basically one of each using the formula in each different way, and then one other one as well. So the first ones are all going to be for things that are speeding up, which is what we kind of commonly think of as acceleration. So if we've got a car, for example, that is accelerating, so it's stopped at the moment and then it's accelerating, so it's getting faster and it's going to reach a speed or velocity of 25 meters per second, and it takes 12 seconds to do that. So the change in speed is 25 meters per second because it's gone from 0 up to 25. We would then write the formula. Now some of you are still dropping marks when you're doing your calculations because you're forgetting to write the formula. You need to do that every time. So acceleration is change in speed over time, and then we just replace the letters with the number that matches up with it. So the change in speed is 25 and the time is 12. 25 divided by 12 is equal to 2.1 meters per second squared. Don't forget the squared. So the next one, we're going to look at what happens if you're being asked to work out time. So in this question, we have got some kind of vehicle which has got an acceleration of 1.8 meters per second squared. So we've been given the acceleration. So that means it's accelerating by 1.8 meters per second every second. Okay. Then we've got the change in speed. So it's accelerating and it's going again from being stationary, but at this time it's going right up to 50 meters per second. So what it's saying is, if it's going up by 1.8 meters per second every second, how long will it take for it to get to 50 meters per second, basically? So then we have to work out time. So we need to look at which version of the formula we want to use. So time is change in velocity divided by acceleration. So t equals change in velocity over the acceleration. Replace the numbers with the ones that match up. So change in velocity is 50 divided by 1.8. 50 divided by 1.8 is 27.8, and it's a time, so it's measured in seconds. Again, make sure you remember the units. For this next one, what we're being told this time is that our vehicle has got an acceleration of 1.5 meters per second squared. So it's going up by 1.5 meters per second every second. It takes 4 seconds to accelerate, and what we want to know is how much faster does it get? So what's its change in speed in that time? So if it's going up 1.5 meters per second every second, and it's doing that for 4 seconds, should be fairly straightforward to work that out. So change in speed is acceleration times time. So again, write the formula and then replace the letters with the numbers that match up. So acceleration is 1.5 and time is 4. 1.5 times 4 is 6. So the change in velocity is 6 meters per second. So it could be that it started at 0 and it's ended up at 6, or started at 3 and it's ended up at 9. We don't necessarily know what the start and the end points are because it's not given us that in this question. But we know that it's changed by 6 meters per second. It's 6 meters per second faster than it was at the start because it's gone up 1.5 meters per second every second. So that's what's called a constant acceleration. It's going up the same amount each time. One more that I want us to just look at quickly is that acceleration isn't always positive. We can have a negative acceleration, which would be a deceleration or something slowing it down. So you've got to watch out for that in questions as well. Okay, so what we'll show in this question, so this time we've got another vehicle, and that vehicle starts at 20 meters per second. But then it's slowing down to 5 meters per second. Okay, so it's going from 20 meters per second to 5 meters per second. It's slowing down, it's decelerating. So then what we need to look at is what is the change in speed. So the change in speed, or the change in velocity, is 15 meters per second. But because velocity and acceleration are both vector quantities, this is where we can add in the direction aspect. Now, direction doesn't always have to be north or south or whatever. It can just be positive and negative, which just shows it's the opposite. One's the opposite to the other. So what we write this as, to make it clear that it's slowing down and not speeding up, is we say that it's got a negative change in velocity. So the change in velocity is minus 15 meters per second because it's gone from 20 to 5. Okay. Now this vehicle took 10 seconds to do that. So then we're being asked to calculate acceleration again. So acceleration is the change in velocity over the time, which is minus 15 divided by 10, which gives us minus 1.5 meters per second squared. Okay. The fact that it's got the minus tells us that that object is slowing down and not speeding up. So watch out for that one. So questions where it's slowing down, you're going to end up with a negative answer because you've got a negative acceleration, i.e. it's slowing down and not speeding up.